Okay, so this is going to be a series of videos in which we introduce the beginnings of the section called dynamics. Grab this, just so I know that I hit all the points that I want to talk about. Dynamics. Now, the way we've been doing things in class, we finish up kinematics, which is the study of how things move. It's modeling motion and predicting what will come next based off of some motion information with position, velocity, acceleration, and time. But dynamics is the section that we go into to expand on that, and it's the study of why things move. We're going to find the causes of motion now. Spoiler alert, the answer is forces. Forces cause things to move. Now, in order to do that, this is going to be a pretty short video just introducing the idea of dynamics and a bit of background on it. The next couple of videos are going to be, well, the main thing that we need to talk about, and is going to be at the heart of all of what we study in dynamics. Newton's laws of motion. Now, Newton is a reference to Sir Isaac Newton, who is a very old, very dead guy from England, as I recall. He ended up kind of changing things in, well, fundamental ways as far as people looked at the study of the natural world. In fact, Isaac Newton is on a short list with people that are considered to be the greatest geniuses of our species. And I personally, though I'm incredibly biased, tend to think that he's one of the first and foremost. He's probably the one that I would put at the top of that list, at least of the particularly well-known ones. There are other people that stagger the mind, like Euler. But that being said, going with this, Isaac Newton was incredibly influential. And the way he was influential was as a result of one of his main masterpieces, his opus, if you will, which is known these days as the Principia. Now, that's the shortened title. It's actually a longer one, but it translates to Mathematical Principles of Natural Philosophy. And in some of the parts of these videos, I want to talk a little bit about that so that we can put things into context. If you've grown up here in the 20th or 21st century, then odds are good you've been hearing about Newton's laws of motion since back when, well, you could barely move yourself, depending on your particular schooling system. That being said, there's stuff that you've heard so often that they're kind of things that you just implicitly accept, but they were a big deal at the time. Specifically, the Principia is something where I feel kind of modern science was first started, or at the very least, I should say, modern physics. This is considered one of the first times that we have what we consider modern physics put in place. And why was that so important? Well, the biggest reason why was Newton brought something new in. And so, well, he wasn't the first one to do it, but he was the one to do it in a very rigorous way and kind of set up everything for us to work with. Specifically, he brought in math. Now, he's not the first person to bring math into this. Galileo did a bit of calculations on it, and then there are others that did graphical analyses that were mathematically based and geometrically based, people like Bird and countless others. So I'm not going to say that he is the first and only person to bring math into it, but he did bring a very rigorous approach to mathematics, to the study of the natural world. Now, one of the things that I'm going to talk about at the tail end of some of the other videos, depending on where it's relevant, is the understanding beforehand. Before Sir Isaac's time, for about 2,000 years, most of Western society, so Europe and even classical cultures like Greece and Rome, they had a level of understanding of the natural world, and it was actually pretty decent, all things considered. I mean, you look at things like the engineering projects of Rome, there are aqueducts that stem back thousands of years and are still chugging along just fine. They did some incredible things, incredible feats of engineering, and many of those were also mathematical based on what they had available. They were operating primarily on an understanding of the world set up by Aristotle, another dead guy, this one from Greece and significantly farther back. He lived about 2,000 years almost before Isaac Newton's time, and he set up basically what was called, up to that point, natural philosophy. In fact, I'm going to write that down because the full title of the Principia was Mathematical Principles, that's the Principia, of Natural Philosophy. So I'm going to write that out. Natural Philosophy. in short, this is what we would call science. What many of the groups thought in Western civilization, from the time of Aristotle on till basically, effectively, Isaac Newton, was they saw the study of the natural world as a pursuit of philosophy. You had people who would use the rules of logic and come in, and much like they would debate other forms of philosophy, they would say, okay, we are going to look at the world around us, we're going to see what happens, and we're going to see if we can explain it logically. There are some rules at work here, and if we understand those, we can understand what is happening in the world. That comes from Aristotle, and was actually starkly contrasted with his mentor, Plato. Plato had an understanding that it wasn't actually go out into the world and make observations. In fact, Plato had a very different viewpoint. He said what you should do is you should close off all the windows, and you should sit and you should think about what the proper natural order would be, and then build off of that understanding. That's not even remotely science by our current understanding. Science relies on going out, making measurements, and seeing if you can figure out what's going on with the world around you. Now, natural philosophy was what they called it and what people referred to them, their pursuit, for thousands of years. In fact, Newton himself would not have called himself a scientist, because that term wasn't around at the time. He would have called himself a natural philosopher. That's why his book is titled Mathematical Principles of Natural Philosophy. They didn't have science at the time, and honestly, it's not mostly, but it is greatly thanks to Isaac Newton that we now have this uniform idea of science. Now, there are plenty of others that I'm leaving out in this description. Bacon and Descartes and others that had a large influence on this as well. So don't take this to mean that I think that Isaac Newton is solely responsible for it, but from the physics viewpoint, he had a profound influence. Because one thing that was noticeably different was Aristotle basically said, look at the world around you and come up with a logical explanation. Isaac Newton said, look at the world around you and analyze it mathematically to see what the patterns are, and then go based off of that. Before we introduce the idea of math and collecting hard data like that, at least for the purposes of physics, then whoever had the best argument would win, whether or not it was the best representation of reality. And we're going to talk about that in a couple of subsequent videos, where this mathematical approach allowed us to take what had been dominant for 2,000 years and finally show that while it was incredibly logical, and at many times far more logical than our current understanding, it made much more sense looking at it from the old way, but the math told us that there was something more complex going on there, and the math kept being supported by what happened in real life. So it doesn't matter whether it's the simple or most elegant explanation. All that matters is what the universe is doing and how we can model that. Now, Isaac Newton was one of the key people who brought that understanding in and basically invented modern physics, a major part of modern science and its techniques in that. In the Principia, he introduced the idea of the force of gravity. That doesn't mean that people before his time didn't realize that they could, if they jumped, they'd go flying off into space. They understood the day-to-day applications of gravity, they just didn't have a name for it. And they had a different understanding of why it happened from Aristotelian physics. We'll talk about that in a much later video on Kepler's laws. But he introduced the idea of the force of gravity, working with forces in general, his 3 laws of motion that actually explain the entirety of the universe, every motion that you see everywhere, and at the same time invented a significant portion of calculus, all in that one book. It is one of the most influential books, especially in physics, but in Western science development at all. Now, we're going to go through and we're going to talk about Newton's laws of motion and try and give a bit of background on those and the important things that you need to take from them. But I wanted to do a primer here where you had an idea of collectively some of the ideas that go into this. We're going to find out why things move, and beyond that, we can use mathematical models to actually predict how they will respond to different stimulus. All right.